Okay, so the next step is we're going to talk about creating algorithms. And what we're going to be doing in this section is I'm going to be introducing you to ways that you can express your algorithms, and that will help you work through the algorithm. So the first thing we need to talk about is what is an algorithm. So I think I mentioned this before, but you can think of it as a step-by-step procedure to solve a given problem. Meaning you're going to have some data coming in, right? And then you're going to be wanting, usually it involves data coming in, right? Because you're going to be, otherwise, that's the whole idea behind what the computer is going to do for you. It's going to be able to take data and understand something from the data, right? We're in data science. So you take that data in and then you do it. Sometimes it's called a black box, right? So you want to figure something out. You want to solve some problem given that data. And then what you're going to end up coming out with is information and knowledge. So one way is called pseudocode, and it's called the language of algorithms. And the idea behind it is that you should be able to think through a problem, come up with the steps, and be able to write it out in English, right? Something that's meant to be read by humans, and not necessarily, doesn't have to necessarily be programmers. Like even a non-programmer should be able to pick up your pseudocode and understand logically how you're breaking down the problem into the steps that have to be accomplished. So just like, let's say a simple example, right? So you want to find out if today is your friend's birthday. So the pseudocode is what you see here on the left, right? You look up today's date. So you think about, okay, so how do I figure out today's my friend's birthday? You need to know two pieces of information. You need to know what today's date is, and you need to know the date of your friend's birthday. So you can look up today's date, right? So this is what it would look like as pseudocode. Don't worry yet. I'm showing you this, what it would look like as a Python program, but don't worry what it's actually going to look like yet. And then you can ask your friend, right? When is your birthday? And then you determine, for pseudocode's purposes, you just want to say you determine if today is your friend's birthday, meaning is today's date, never mind the year, month, and day, similar to or the same as your friend's birthday. And then if today is their birthday, then you can wish them a happy birthday. Otherwise, you tell them today is not their birthday, right? So once again, this is a flow of a pseudocode, and you don't have to worry about what Python is. In our case, it would be Python programming, but it's just the concept of you take the problem that's put in front of you, you figure out what pieces of data that you need, you figure out what you're going to do, and then you're figuring out what your output is. So this is your input, this is your determination, but this is your question, your quote unquote procedure, and this is your output. Pretty simple. Now, another way that it could be expressed, and this is a much more formal way, is you do something called flowcharts. And I like to think of flowcharts as being like the art of algorithms. So to put a flowchart together, and sometimes, it's the art, but even though you're seeing that there are different symbols that you need to use, the idea for it, sometimes people think well in pictures, right? So you can show something in a picture, how the flow is, and that picture could be so much easier to read and to understand at first glance than any kind of, even pseudocode that you're putting out there. So, the oval just represents the start and the end of a program. You can have some input operation, and that's going to have your parallelogram. Your rectangle is going to be some kind of a process, like the examples that you're giving here is addition, subtraction, or some other division, right? And then a diamond is a decision. So, right, so like in this case, this area here, the if today, that would be your decision. So if it is, you want to go in one direction, and if it's not, you want to go in another direction. And then this could be your output operation. So this would be where you would print the output of, happy birthday, or this is not your birthday. So let's just, right, so this is what the flowchart would look like for today's birthday. So you're going to look up today's date. I guess you also have to have the input. There should be one more thing here to get input from your friend, what their birthday is. Then this shows your decision. If today's month and day is the same as your friend's birthday, then you follow this path. If it's true, then you say happy birthday to them. If it's false, you say no reminders today, whatever. This is not exactly the same, but it's very similar to what we did. And you can see what the flow is. So start and end, some input, some decision, and then the decision usually have at least two boxes coming out of it, one way or the other way. You can have more than two boxes because doesn't only have to be a Boolean question that's being asked. This is another example of a flowchart. Here you're finding the average of three numbers, right? So your algorithm could be, right, you're asking the user, here's your input, to enter their three numbers. You're finding the sum of the three numbers, you're dividing them, and then if the result is less than 10, right? So then this, I guess, is part of what you were told to do, that if the sum of the three numbers is less than 10, then if it's false, you put pass on the screen. If it's true, you put fail on the screen, and then you hit sum end, right? So once again, you have input and output. You can see now it's not a full circle, it's more of an oval. You have input coming in, you have these processes, you have a decision being made. It's bifurcating because this is also a binary decision, and then you're having your actions being taken, coming to an end in the end, right? There are certain control structures, right? So sometimes it's called a sequence control, and that's what you were seeing like in this three, where it's just 1, 2, 3. One has to happen before the other has to happen, right? So until you get input from the user, right, you can't sum the numbers and you can't divide the numbers, right? So that's your sequence control, where it's going in sequence. Then you have your decision control, right, where you're having your triangle, your diamond shape, where you're making the decision, is this true or not, right? And then you're going to go one way or the other, depending upon what the output is. And the last is a loop control. And we're going to be discussing these structures further going on. I just want you to see how these structures are being displayed as a flowchart, okay? So here, right, so you're asking them to enter a positive number. And then if it's positive, then you can continue on. If it's not positive, then you want to loop back and ask them once again to enter a positive number, right? So once again, so you have your sequence where it's just going 3 straight down in a row. You have your decision, right, where you're going down one path or the other path, and you have a loop control structure where you're potentially coming back around and looping back around within the same program. Okay, that's the end of this section. And the next section, we're going to be covering computational thinking.